All right, welcome to the Golden Path to SpringOne. I'm your host, Dan Vega, and today we are lucky enough to have our special guest, Maciej, who's going to be talking to us about what's new in Spring Cloud AWS 3.0. Before we get started, though, I thought I'd have to give him his proper introduction here. Maciej is a content creator, a YouTuber, a blogger, very active on Twitter, and that's where I actually met him. He's very big into in the open source world. Working on Spring Cloud AWS, the Century Java SDK. He's a Spring contributor. He released a tool called Just for the Spring ecosystem. And just this week, he released a new project called the Spring Boot Startup Report. Maciej, how are you doing, my friend?
I'm doing very good. Good afternoon, everyone. Thank you for having me.
It's great to have you here. I'm really excited about this talk. I'm big into the different platforms and learning more about this project that I've had my eye on for a while. But like everything, there's so many things to juggle and learn. So I am excited, just as everyone else is. I'm excited to learn today. And with that, I'm going to turn it over to you. And I will mention, if you have questions, go ahead and put them in the chat. And as they come up, I will go ahead and pop them in and we'll ask them and we'll get some responses. So please go ahead and ask your questions. And with that, I will turn it over to you, my friend.
Thank you, Dan. I hope my slides are visible. Today, we are going to talk about what's new in Spring Cloud AWS 3.0. And for those who are unfamiliar with Spring Cloud AWS, its goal is to simplify using AWS managed services in Spring Boot applications. So you can also think about it that it bridges the gap between relatively low-level AWS SDK and provides a Spring idiomatic experience that you are familiar from other Spring modules or other Spring libraries. It is not a deployment tool, and in fact, your application doesn't even need to run on AWS. It's just enough that you use certain AWS services, and then there's a high chance that you will find the Spring Cloud AWS useful. To understand the steps we took to develop Spring Cloud AWS 3.0, it's worth to look a little bit into the history, how the Spring Cloud AWS even started. So back in the day, so there are around like 2011 till 2015, AWS was relatively simple. So there were just small number of services, and EC2 was the only compute platform available to run applications. And in 2011, Agim Emruli, who originally started this project, he started working on a project called Elastic Spring that later on transformed into Spring Cloud AWS. And important thing here is to note that in 2011, it means that it was a couple of years before Spring Boot and Spring Cloud were even created. So this means that Elastic Spring was made with Spring Framework in mind and the patterns that were popular when developing a Spring Framework application, so XML namespaces and so on. In 2015, Spring Cloud AWS 1.0 was released. And back then, the idea was that when Spring applications run on AWS, they use the most typical services. And the core library assumed that you are going to use S3, that the infrastructure will be provisioned with CloudFormation, and it will run on EC2. And all of these assumptions made a lot of sense in 2015, when the AWS was relatively small, and this is just the way we developed applications back then. But the world has significantly changed since 2015. The cloud computing exploded, and not only AWS expanded their service offerings, but also the whole ecosystem around AWS and Spring Boot just boomed. EC2 is not anymore the only way to run applications. There's also ECS, Kubernetes, and AWS Lambda. And CloudFormation, although it is still the default way to provision infrastructure, it has some strong competitors, specifically Terraform, which is extremely popular. Also, AWS released a new version of their SDK, a modern version of their SDK called AWS SDK v2 for Java. in the Spring ecosystem, Spring Boot has become a standard. It's very rare to see new applications built without Spring Boot, just with pure Spring framework. Kotlin has become a number 2 language in JVM. And also, we somehow started to worry more about the startup time. Also, in the parallel, in 2020, somewhere at the beginning in 2020, Spring team decided to move out all the public cloud related Spring Cloud projects out of the release train and also out of the GitHub organization. So it means Spring Cloud GCP, Azure Spring Boot, and also Spring Cloud AWS. And Spring Cloud AWS has always been a community project. It was under Spring Cloud umbrella and in Spring Cloud organization on GitHub, but it has never actually been primarily maintained by the Spring team. So it was clear that once it moves also from the organization, it was clear that the new maintainers are needed. And this is where personally our journey has begun. So it's me, Maciej, and Edu. We took over the project with very ambitious plan to fix the bugs, implement the features that we all wanted ourselves, but also that community asked for, and finally migrate to AWS SDK v2. Currently, the team is slightly different because Edu moved on and he joined Atomic Jar and he's working now on test containers. But Thomas joined us with his in-depth experience from working on Spring Kafka. So when we started developing Spring Cloud AWS 3.0, we had a couple of points in mind. So first of all, it must be migrated to AWS SDK v2. And these SDKs are maybe not very different, but they are different enough that it meant for us that we practically have to rewrite a big chunk of the project. We also wanted to make Spring Cloud AWS feel more Spring Boot native. So to provide the same quality of integration as other Spring modules do. So it's like a predictable auto configuration, but also easy to customize. Because keep in mind that the Spring Cloud AWS originally was created for Spring Framework, and then integration with Spring Boot was kind of like added on the top. And you could definitely feel it when you wanted to do something that is not exactly like when you just wanted to do something that is not a default way of doing things. So we also wanted to reduce the startup time, even though the startup time, maybe this is not like the most critical issue, but we wanted to remove the dependencies to S3 and CloudFormation because there is no point to bring them when you just don't really want to use them. We wanted to make all the integrations modules independent from each other, which means that if you want to use SQS, you just add SQS dependency. It doesn't mean that you have to bring suddenly S3 or Secrets Manager or anything like that. Also, because I'm personally a fan of Kotlin, and in my let's say surroundings, the Kotlin is a very popular language. We wanted to make the project a little bit more Kotlin friendly, so we annotated all the APIs with nullability annotation so that in Kotlin you don't have to guess if something can be null or it cannot be null. So we basically follow the same thing that was done in Spring Framework a couple of years ago. And we also wanted to simplify testing and specifically simplify integration with Localstack, which is both for testing or for just running application locally. So now let's take a look at the most important integrations, but also most important changes that we introduced in Spring Cloud AWS 3.0. Starting from S3. If you're unfamiliar, Spring S3 is an object storage built to retrieve any amount of data from anywhere. This is from the AWS website. But practically speaking, it's a place where you can store files, but not just files. You can store them files with metadata. These files can be encrypted. So it's like a very powerful file storage. And Spring Cloud AWS came with integration with S3 from the very early days through a Spring Resource Abstraction. Spring Resource Abstraction is providing like a unified interface for accessing files from file system, class path, or even over the wire like HTTP or FTP. So Spring Cloud AWS just extends this feature to also support S3. You just put the S3 path and then it suddenly gets resolved from S3. In version 3.0, we've added a very highly demanded support for S3 object metadata. So now whenever you upload a file to S3, you can set the object metadata through, I think, very convenient API where you just have auto-completion. You don't have to guess the strings and so on. That being said, I find that many Spring developers don't use the resource abstraction and also don't see it as a natural way for uploading or downloading files. So we have introduced in 3.0 S3 template, which is kind of like a wrapper on the top of the S3 client, which brings a very similar experience to any other template class that you may know from Spring Framework. And in addition to quite obvious methods for upload and download, it also has the capabilities to create and delete buckets. And I think important thing is that it also handles the S3 URL signing. And in addition to that, we added a capability to store Java objects in S3, which is quite uncommon, and S3 definitely shouldn't be used as a key value store or as a database or anything like that, because there are better options. But I think there are some scenarios where you just want to take an object, serialize it to JSON or any other format, and just store it in an S3 bucket, which then will trigger either Lambda or it will be processed later on by some batch job. So by default, we provide automatic serialization to JSON, but you can also plug in any other serializer that you will need. And there are also a bunch of other less visible changes, but I know from the issues that came to Spring Cloud AWS project, I know that they can dramatically change the experience of using the framework. So we have, for example, a cross-region S3 client that is actually used by default. You just don't see it because you use the S3 client interface, but it transparently handles working with S3 buckets that are in the different regions. So as soon as your application has access to access bucket in a different region, then the cross-region S3 client handles it automatically. And also we realize that there's just no really one single right way to upload files. So we provide 3 different implementations of the output stream. The one that is buffering changes in the memory, another one buffers them on the file system, and another one uses the AWS CRT client with transfer manager. This is a very recent addition to AWS SDK. Another service that I would like to talk about is SNS. SNS is a managed pub/sub service for application to application and actually more messaging. So the basic idea is that you create a topic on the AWS side, and different components can subscribe to this topic. It can be AWS Lambda, it can be SQS-Q, it can be also an HTTP endpoint. And then the application can publish a message to a topic, and then it will be automatically distributed to anyone who subscribed to it. So Spring Cloud AWS comes with a very convenient Spring MVC annotations and type resolvers to simplify handling these HTTP annotations. And this has been actually there since a very long time. We didn't introduce anything new here except migrating to AWS SDK v2. But there is one catch. AWS SDK v2, in comparison to v1, does not provide a verified SNS message signature. So that means that whenever the message comes, SDK doesn't provide a way to make sure that this actually came from SNS and not just someone, is mimicking the SNS request. So if you are concerned about receiving fake SNS messages, you must implement this verification yourself, or you can include the AWS SDK v1 and do the verification from there. It's not very convenient, but we decided to not implement ourselves, but rather wait for AWS team to do it. And then we have also SNS template for the part of sending messages. So there are multiple methods, very convenient ones that handle automatic deserialization. It also works with the Spring messaging interfaces. And also we've added a new method for sending complex notifications where you have this nice API that just auto-completes, like a fluent interface that auto-completes it for you. And this is especially important for sending messages to first in, first out topics where you have to provide a group ID, where you have to provide a deprecation ID. But SNS is not only about sending notifications to other applications, right? You can also send text messages, so SMS, with SNS. And it works in a way that the mobile device is subscribed to an SNS topic. And then you can send a message from your application to an SNS, and then it will just distribute it as a regular text messages. But the API to send text messages is quite inconvenient because you have to use a lot of special attributes as a string. So we decided that we can do it better, and we provided SNS SMS template where you just send a message. We specify what is the phone number, what is the message, what is the content of the message, and then again this fluent interface for setting all the possible properties, because there are quite a lot of different options to send. Like it can be a promotional SMS, it can be like a regular one, and so on.
So we had a quick question here. Great.
Yes.
How will this work with Spring Webflux?
It doesn't. That's the like if we talk about this handling HTTP notifications, we don't have integration with Webflux.
Okay.
And let's say PRs are welcome. So there's nothing against Webflux. We can add it.
Yep.
We just decided that we have other priorities.
Yep. Great. Okay. Thank you.
Okay. And then we go to the Secrets Manager, and this is like extremely important integration. Secrets Manager is a place in AWS where you store secrets, so database passwords, API keys. And AWS has some certain features like to rotate the secrets and basically to comply to any regulations that your application must comply with. And there is a Secrets Manager client where you can just fetch these secrets. But again, this is not extremely convenient way, especially when you are used to other Spring integrations like Spring Cloud Config Server or Vault. So we've added a dedicated way to receive these secrets, but make it feel very Spring idiomatic. So it works in the following way. You create a JSON file where you set the properties, then you create a secret on the AWS side, and then with this Spring config import, and you put the prefix as AWS Secrets Manager, you set the name of the secret, and then automatically whatever was in this JSON is propagated to the Spring environment, and you can either bind it to configuration properties or you can refer to it with a @value annotation. This has also been there in Spring Cloud AWS since 2.2, I believe. But in 3.0, we've added a very important feature to an option to set the prefix, because there is a chance that the same key that is used in the secret will be also used from, let's say, in application properties or any other property source. So in this case, you would have a collision and one will overwrite another. So now you can set the prefix, and it means that all the properties that were set in the JSON file will be prefixed with whatever you set as a prefix, right? So in this case, you said that it's db dot, so it means that it won't be just available as a username, but instead it will be available as a db dot username and db dot password. Other than that, in 3.0, we added support for plain text secrets, where you don't set secrets as JSON file, but rather just a single value. Also binary secrets, and we've added an option to reload secrets, because as I mentioned, Spring Secrets Manager can rotate the secrets periodically, and your application may end up with an invalid secret. So now there is a way to refresh the secrets periodically. So you say that like every 1 minute you want to refresh the secrets, or you can also integrate with the actuator refresh endpoint, or rather refresh event, that whenever the refresh event is triggered, then the secrets will be fetched again. DynamoDB. DynamoDB is one of the, I think, the most popular NoSQL databases in general, but definitely the most popular in AWS. We've added a DynamoDB template, which sits on the top of DynamoDB enhanced client, and it simplifies the CRUD operations. Let's say, you will see in a second how does it do it. And we've also added a DAX support. DAX is like a layer on the top of DynamoDB that provides it's like a caching layer. So again, like you just add the DAX dependency, set the DAX URL, and automatically, like for application, it will be completely transparent, but you will just hit first DAX before it goes to DynamoDB. So if you are familiar with JPA, it looks a little bit similar. You annotate your classes with annotations from AWS, from a DynamoDB enhanced client. And then with a DynamoDB template, you can have like a simple CRUD or search operations. What Spring Cloud AWS does automatically for you is also automatically registers a table schema and also provides a table name. So it's like a little bit more convenient way than you would do with a regular DynamoDB client. And then we go to SQS. SQS is a fully managed queuing service, fully managed message queuing for microservices, distributed systems, and serverless applications. And it's like a default, I think, the messaging option when you are on AWS. And the integration with SQS is especially important because it's extremely difficult to use SQS without a good integration, just with a pure SDK. And especially if you are familiar and used to working with, let's say, Spring AMQP or Spring Kafka, where you just annotate your methods with listener annotations. So Spring Cloud AWS provides something very similar. We have a SQS listener for listening for messages, and we have SQS template for sending messages. In 3.0, we completely rewritten the whole SQS integration based on the battle-tested Kafka architecture. And when we say we, it's actually 98% Thomas and 2% me checking the pull request. So first of all, he addressed, I believe, all the bugs that we had in SQS that we struggled to fix in the previous implementation, but also added asynchronous listeners, batch listeners, and support for FIFO queues. So now it works in the following way. You can just listen like a regular, like you used to before. So the listen method just takes whatever goes in the payload, and then you can fetch some extra data from the message itself, like using the header annotation. You can manually acknowledge the message, and you can also, the feature that I like the most is the batch listener. So it means that whenever you fetch the messages from SQS, they always come in a batch, and you don't have to process them individually, but you can take them all at once. And also it benefits from the asynchronous and non-blocking nature of the AWS SDK v2. So now the SQS listener can return a completable future, and it also means that the whole processing can be done asynchronously, but also non-blocking. In addition to that, we also have a parameter store integration, which works very similar to Secrets Manager, but it's primarily not meant to retrieve secrets, although you can also store their encrypted strings. You can also send emails with SES, and we provide the auto configuration for CloudWatch integration with Micrometer. And now I would like to switch to the demo. It will be a very simple demo just to show you some parts of the Spring Cloud AWS capabilities, but maybe even more importantly, it shows you how to like the experience of developing applications with Spring Cloud AWS. So I have here like a skeleton for a very simple application that takes a request to download images from a website. So you just provide a website URL, and then we parse the HTML content, find all the, it's actually implemented here, right? So we find all the images, and then we want to download all of these images and put them to S3. And right now there's no Spring integration here at all. So the first thing that I have to do is I need to add the dependency to Spring Cloud AWS. And I know that this is obvious, but the important part here is that you will not find Spring Cloud AWS when you go to start.spring.io. And you might be wondering why. And the reason is that to be on the start.spring.io, you have to meet certain conditions. Let's say when the new version of Spring Boot is released, you should release it relatively soon after, which makes total sense, right? You want these dependencies on start.spring.io to be very reliable and very up to date. And since Spring Cloud AWS is a community project, we cannot guarantee this because we just do it in our free time. So we have to just do it manually. You have to set the dependency management, and I'm using snapshot version, but you can use currently the latest one, which is RC1. And then we just add the dependencies to the modules that we are going to need. So we definitely need a dependency to S3, but we also want a dependency to SQS, because like fetching the website, scraping the content, downloading images, this can take a long time. So we don't want to block the request itself. So we will just do it in the background. So we are going to add a dependencies to SQS or to DynamoDB. No, sorry, not to DynamoDB, but to SQS and to S3. Okay, good. Now, when we have a controller, we can inject the SQS template, and we just want to. Whoops. I hope you can't hear my laptop too well. So, and then we just say that we want to send the request. No, sorry, we do send. And we do, what's the endpoint name? This will be my queue. And then we send the request. And the request contains just a URL. So then the message will end up on the queue. And then we have a listener. So we annotated with an SQS listener, which is also quite, I hope it's quite obvious. So we say that this goes to my queue. And then by default, if we don't set any annotations over here, it will just take it from the message payload. So it will find images using the scraper. And then there is this relatively weird code. But the point is that we don't want to download these images to a memory, but we rather want to stream them. So we open the stream from the whatever we downloaded, and we just want to pass this data to S3, because there is a chance that these images will be large, and we don't just want to keep it in the server memory. So we will add here an S3 template. Okay, and now we do S3 template, upload, and we say what's the bucket name. So it will be my bucket because I have already created them. For a key, we take a file name. And now we need to pass the input stream, which comes in this case from the response body. And this could be it, but we can also set the object metadata. And in general, it's nice to set the content type object metadata at least. So we set the object metadata, and then we set the content type is whatever we received here from the headers. So now when the file is uploaded, we have a listener. And I think this should be actually all that we need. But we will do something different here. When I'm developing the application, ideally, or maybe when I'm learning or when I'm developing and I don't have to use directly AWS, maybe I don't have to. So there is an alternative to run an AWS kind of like a simulator locally, which is called Localstack. And Localstack just provides the local implementation of AWS APIs. And this is the tool that we use ultimately for testing for running all the integration tests in AWS. So here I have a Docker Compose file that starts the Localstack, and I have the Localstack already running over here. And I just need to point my application to use Localstack instead of using the real AWS. And I'm pretty sure that I have a shortcut for that, but I don't remember. So we need to set the endpoint. The endpoint is localhost 4566, because this is where the local stack runs by default, and this is the port where I expose it with Docker. And we also need to set something on S3, which is a have style access set to true. And this is, I'm not sure exactly why, but this is, in this case, this is local stack specific. Without it, it will not really work with local stack and S3. And now let me run the application. Actually, I don't even need it here, I guess, but let's leave it. So this is a piece of code that I used to create the bucket and create the queue on application startup. You should not do it in real applications. You should use some real infrastructure provisioning. Okay, so it says that the port is already in use. Sorry. Okay, so now the application is up. No, it's not up. What happened? Because there is already a bucket. So we don't need it. Okay, so the application is running, and now I hope that it will actually work. So I will take this URL as an example. So it should download all the images from this website. So there's one over here, one over there, and maybe some others. We will see. So now, if I go to the terminal, which I will have somewhere here, and then I run curl. So I pass the URL. I didn't add any logs, but if I do S3 list objects on my bucket, I should see that these files are uploaded. So it uploaded the 4 files, and this is because I have already found out why, because there are also some avatars on this website. So with this demo, I hope you have a little bit better feeling on how to use Spring Cloud AWS, and most importantly, also how to use it together with a Localstack. Localstack is very handy when running it for development, but most importantly, it's very handy when you want to test it. So let's say if you want to test your application, write an integration test, you can use the Localstack integration from test containers, which spins up the Localstack automatically for you, and then you just need to pass the Localstack URL to this property, and then your application will run integration tests without even touching AWS. Okay, let me switch back to the presentation, and we will see now the a little bit darker side of Spring Cloud AWS 3.0. Because if you look at the list of the services that we supported in 2.x, it was a little bit longer. So we supported also RDS, EC2, Elastic Cache, and CloudFormation. And in terms of RDS, we may actually bring it back, but we decided that Spring Boot should implement it first. Not exactly the integration with RDS, but specifically the support for having the primary database and also the read replica database. And then our integration with RDS could just basically orchestrate it properly for RDS instead of implementing this whole support by ourselves like it was in 2.x. In terms of other integrations, we simply did not do it because we didn't have time. So again, if you would like to contribute to the project, and especially when you use it, then you are very welcome to come with an issue or submit a PR. And that being said, you can still use RDS or any other integrations with Spring Boot. The only thing is that Spring Cloud AWS does not provide the out-of-the-box dedicated integration for it. So what the future holds? So first of all, we talked this whole presentation about Spring Cloud AWS 3.0, but in fact, this is not yet released. I mean, the release candidate 1 is released, but we haven't released yet the GA. And this is going to happen relatively soon. Today we had a short team discussion about it that actually we are quite ready for a GA. For 3.1 and 3.2, we want to provide the native image compatibility with GraalVM. Right now, you can already run Spring Cloud AWS with GraalVM, but there are some small missing bits. So if you really need to, we recommend that you use the GraalVM tracing agent to discover all the missing native image configuration properties. In the next step, we also want to add the observability support with micrometer tracing, and of course, add more integrations, especially that for some of them we already have pull requests. So it's app config, cloud map, and maybe we will bring back RDS. You can find us on GitHub in AWS Spring organization. If you find this project useful, I would appreciate if you give it a star. And if you would like to contribute, and especially when you use Spring on AWS, so when you have a production experience, it will be great for us and also great for the whole community if you could just share your solutions. If you have any questions regarding the project, we have a discussion section where you can create a question or just to discuss. And if you would like to reach out directly to me, I think Twitter is the best way to do it, and there is a handle on the bottom of the slide. Thank you for listening.
Awesome. Thank you for that. So I have a couple things that we'll get to in a second, but I had a couple questions of my own. So Localstack, I haven't heard of that before. I mean, I think I've seen it, but I haven't used it before. So when you spin up like a local instance on your machine, if you're using something like S3, does it like write an object to your disk locally then, or how does that work?
It's completely abstracted. Like you don't know. I don't even know where it actually writes it. I believe it does write it somewhere, but you just use the same APIs as you would normally use with S3. So you can just list objects, you can sign them, you can expose them over, I believe, CloudFront version of Localstack and so on.
So the idea is, hey, we're just testing everything, but we don't want to use real AWS yet because we're not ready for that. We'll move to that a little bit later.
We are not ready, or you are learning how to use AWS, or you're experimenting, or I think especially when you run integration tests, like on your CI, you don't have to deal, with spinning up the separate like environment for different builds. You don't have this problem of colliding and so on. And also Spring Cloud AWS 2.x, we used to use real integration, like real AWS services, but running the test took 1 hour because this is how long it took to spin up the
the infrastructure.
The RDS, Elastic Cache, and so on.
Yeah, that makes total sense. Cool. Well, that was awesome. So you mentioned a couple times about this being a community project, hoping that we can get more folks involved. Are there any things that like stick out to you that really need some attention right now, or do you just want folks kind of testing things out, running it through kind of what they need to do with it and providing feedback? What's the best place to kind of help you guys out with this project?
So we, in general, get a lot of feedback when we break something, right? Because like there are big companies that use Spring Cloud AWS and they always come back to us with issues. So I think this part we have quite well covered. But the two things that I would really appreciate if someone from the community could contribute is exactly the Spring native integration, so the GraalVM native image, and also the observability. Because both of these, they require quite a bit of time that I know that I will not have in upcoming weeks.
Yeah, I know. I've done some demos on just some basic GraalVM native image, providing some of those hints in just like very basic applications. And even then, there's a lot that goes into that. So, the more that I saw, what the Spring team did with all the projects in the ecosystem, the more I was amazed, like, wow, this was a lot of work to get all this done. So
and the results are awesome, but it's also just takes so much time to build these native images to test it. The whole process is a little bit more painful than I wish it was.
Yeah, and even sometimes some of those hints work, and I've had times where not all the hints come out exactly how you want them to be. So, um, cool. So I had a couple just like questions and comments in here. Our friend Philip was in here. He wanted to say, "Hey, really nice slide animations," and I'm gonna agree with Philip on that one.
Thanks,
So,
Philip.
we had another one. I think I know the answer to this, but just wanted to run it by you. Does this tie me into AWS? And this is Spring Cloud AWS. So I'm guessing yes.
Yes, like I mean, when you are on AWS, you can choose to use their managed versions of open source software. Like they have the RabbitMQ, they have Postgres and so on.
Right.
So you can totally be on AWS and be not tied to AWS exactly. But for these kinds of services, Spring already has a magnificent integrations, right? So Spring Cloud AWS basically provides the integrations for the proprietary AWS services. So definitely ties you to AWS.
Like if you want to build a Spring Boot project and post and launch it on like EC2 and it's going to connect to a DynamoDB, like this is where you should start.
Yeah.
Friend Simon says, thank you for the nice demo. I've got a whole bunch of thank yous. Can you advise a learning path for a newbie? That's a pretty overloaded question. I think the best place to get started with is just head over to the project, check it out, check out the examples, documentation, go through that first. That's probably a really good place to start. And then, go ahead and if you run into issues, that's a really great place to start in being able to contribute back to the community. Hey, I had this problem. This is what's going on.
I do have one suggestion though. The friend Philip, who just wrote before the message about the slides, as far as I remember, he just today released a new version of their stratospheric video course where they teach how to use basically not only Spring Cloud AWS, but how to deploy and run Spring Boot applications on AWS. So they cover Spring Cloud AWS, they cover provisioning the infrastructure. So I think this would be a very good starting point for a newbie.
For sure. Yep, and there's a book with it. I have the book, so check out the book as well. I have another question here. Example, I have two services. Service A gets a request from body request and then sends messages to SQS Localstack, and then service B has a listener entry point to SQS and print the message, send it. I think he's just confirming the demo that you went through. I don't know if that's an actual question. Sorry. Does this project aim at making the integration with AWS services easy? What's the downside of using the AWS SDK? So I think that's a great question.
You mean like to use the AWS SDK directly?
Exactly. I think that's what.
I mean, there is no like specific, like under the hood, we use AWS SDK, right? So we just provide a more convenient way to use it in Spring Boot. Like if you are fine with using AWS SDK and this matches your needs, probably you are good. Like maybe you don't need another layer of abstraction, right? But if you will try to, let's say, use the secrets manager or parameter store or SQS directly, just with using pure SDK, I am pretty sure you will have some pains.
Given your experience, I'm going to believe you on that one. Cool. I think that's really all I have. Anything else that you would like to kind of close this off with?
No, I'm super grateful that I had a chance to to share my share about stuff about Spring Cloud AWS. I'm very grateful also for the community, because this project is basically like there are 3 of us in the core team, but of course there are so many other people who contributed with pull requests or issues and testing. Sometimes it's even too much and I can't handle it. But it's great. I mean, it's a great experience.
Awesome. Well, we really, really appreciate your time today here on the Golden Path to SpringOne, for sharing what's new in Spring Cloud AWS. And as we leave, I'm just going to share a couple of things. We've talked about Spring Academy before. This is a great place for on-demand education developed and curated by the world's foremost experts in Spring. If you want to learn more, you can create a free account. You can register for free at spring.academy. And we also are, this is the Golden Path to SpringOne. We are leading up to SpringOne at VMware Explore in August. So August 21st is actually my birthday. So join me on my birthday in Vegas at SpringOne at VMware Explore. The CFP for this ends at the end of March. So March 31st. You have another 10 days as of today to get those CFPs in. So please go ahead and submit those CFPs. We'd like to see you there in Vegas with us at VMware Explore. With that, we will go ahead and close this out. Again, thank you everyone for joining us and have a good day.
Thank you.